Okay, so we'll start with the fourth numerical. In this, it is said that a cast iron beam has an I section with top flange as 80 mm by 40 mm, web as 120 mm by 20 mm, and bottom flange as 160 mm by 40 mm. This is the dimensions of an I section beam, right? Top flange means the upper portion of the I section, web means the vertical portion of that I section, and bottom flange is the bottommost portion of the I section, right? Okay, and it is not normal usual I section, it's a irregular I section in which upper flange and bottom flange are different dimensions. Okay, then if tensile stress is not to exceed 30 Newton per mm square, I'm sorry, it is a mistake, 30 Newton per mm square, and compressive stress is 90 Newton per mm square. So in this, he's told you that tensile stress is not to exceed 30 Newton per mm square, and same way compressive stress as 90 Newton per mm square. Okay. Then he is asking what is the maximum UDL, maximum uniformly distributed load, that is UDL. We say the beam can carry over a simply supported span of 6 meter if the larger flange is in tension. What do I mean by this? That larger flange is in tension, I'll tell you, right? And UDL, he's asking UDL. Okay, so let us try to solve it. In this, we'll first draw the figure of the beam, and let us say this will be the figure of the beam. Okay, in this figure it is said that 80, 40, this is 20, I'm sorry, this 40 dimension, and this, it is actually 20, so I should have drawn this in a smaller way. Okay, but please excuse me for this. And this is 40, and he already told you that sigma t is equal to 30 and sigma c is equal to 90. Is it okay? See, actually this version of writing is not correct. It is wrong. You should not write it. Earlier I had not written it like that, but then I copy and pasted it to Paint and written it in this manner, so that this is the version of the 70 to 80% of students, if they try to solve this numerical, that they'll write down that sigma t is 30 and sigma c as 90, whereas actual scene is not like that. So in what way you have to write down is that sigma t is not to exceed 30 Newton per mm square and sigma c is not to exceed 90 Newton per mm square. This is the correct way of writing, and this procedure is wrong. You should not write in this way. Okay. Now, then he's saying what is the maximum UDL the beam can carry over a simply supported beam of span if the larger flange is in tension. This larger flange is very important, right? What do you mean by this? See, this is the, let us say, beam. He is saying the larger flange is in tension. Now this beam will bend like this. This beam will bend like this. Okay. This is the beam, and this beam will bend like this, right? So in this, the lower portion of the beam will expand. There will be tensile force in it. That's what the theory of simple bending says. That means the larger flange will experience tension. That means this beam will draw, the side view of the beam will be like this only. Otherwise it can be of opposite type. That means the larger flange, I could have drawn this larger flange on the upside and lower flange and this shorter flange on the downside, but I had done this because in this it is written that larger flange is in tension. I hope this concept was clear to you. Okay, Then what is the maximum UDL? Okay, so for UDL, you know the formula is W into L square upon 8, and this is the complete formula. M over I is equal to sigma over Y, and you do not know what is I, you do not know what is sigma, you do not know what is Y. Of course, we know what is sigma and we know what is sigma, but ultimately I do not know whether I have to put sigma T or I have to put sigma C, right? Or I can put any value, I do not know still. So these are the few questions, and let us see how to answer these questions. Huh? Is it okay? I think. Okay. Next. Now again a challenge. First you have to find out the centroid of this shape. This is the shape, right? And you have to find out the, okay, you have to find out the centroid of this shape. So then the centroid of this shape is, this is first shape, this is this shape, and this is this shape, and this is 18 to 40 area, x bar, y bar, considering this point O as origin, right? Now if you calculate the y bar, then we'll came to know that y bar is 73.75. okay. Just I have to zoom it a little bit. Sorry. Okay, let us try to solve it like that. So this is the I'm sorry. Okay. Now this is the diagram of this beam, the side view. Now from this we can see that the lower side is in tension, so this side is YT, right? And the upper side is in compression, so this side is YC. And now you have to understand one point very sincerely, that these sigma C and sigma T, these two are the two maximum values of that can be experienced by any beam, right? Now it will not be that particular beam will fail because of tensile stress, or that particular beam may fail because of compressive stress. That means the permissible limit of tensile stress is only 30. That means the beam, if it will experience, in case of tensile stress, let us say 35 Newton per mm square, then it may fail because of tensile stress. But in that case, it is not necessary that it will experience more than 90. It may experience less than 90 also, but it will fail because of tensile stress. Same is the case for compressive also, right? So this is these two values will not go together. These two are the two permissible limits of tensile and compressive stress. Now in this, how to deal with this situation is, sigma C over YC is equal to sigma T over YT. This we already know. And from this we'll get the relationship between sigma C and sigma T. From this it is very clear to me that if sigma C is 90, let us say in the beam, if compressive stress reaches its maximum value, then what will be the tensile stress? Tensile stress will be sigma T will be 52.574, and that value is against the permissible limit. So this option will not work at all. That means the other option is what? That sigma T is equal to 30 Newton per mm square and sigma C is equal to 51.36. And how this 51.36 and 52.574 has come? It has come from this derivation, right? So that means this particular option will go. Why? Because in this it is under the maximum tensile stress, that is 30, but it is well below its compressive limit, that is 51.36. So this option is okay. That means I can put the value of sigma T and I can put the value of YT. And again, to find out the value of W, I have to go choose this formula. So sigma T is okay. On this side YT is okay. The M value is W into L square upon 8. But again, I is still a problem. So you have to calculate the value of I. And I, there is no need for me to tell you right now, because it is the you had already covered this the value how to calculate I in case of centroid and moment of inertia. So you have to first calculate the moment of inertia of this beam about its centroidal axis. Then you have to put that value of I into this equation, and then only you will get the answer of it. Right? I hope this session will be okay, and sorry for some mistakes in between. Right? Okay. Thank you.